Whoops, what am I doing? Problem number 10 from 1.4. Problem number 10 says we have the parametric equation x equals sine of 2 pi t, 2 pi t. And I might need to borrow some of these calculators. I got my calculators and I have batteries, but then the operating system's messed up. All my excuses. Y cosine of 2 pi t and so what they're asking us to do, part A, we need to graph the curve, okay? And then part B, we need to find the Cartesian equation. So I'll graph the curve on my graphing calculator on my computer in a second, but let's try to figure out what the Cartesian equation is. So since we have sine and cosine, all right, the most common thing that whenever you see sine and cosine, you should think of a trig identity. So usually we're going to use this trig identity, sine of theta, and I'll write it a little differently, plus cosine of theta squared is equal to 1. Now sometimes if it is an ellipse, we might even have something like something over A and then something over B, right? That's usually the case when you have sine and cosine. Now, since they both have the same coefficient, in other words, this is 1 sine 2 pi t and 1 cosine, I'm pretty sure that we're not going to have the x or the A and the B part. I think this is a circle. So now if I graph this thing, what we'll find is, let's do it all by hand because that's the best way to really grasp your mind around it. Let's make a table of values. Okay, so I've got t, I've got x, and I've got y, and we're going to pick 0, pi over 2. These are all the ones we're going to plug in for t. Pi, and then did they give us a boundary? Yeah, it was
0 to 1.
T equals 0 to 1.
Yeah.
Oh.
So you can't do either of those. Yeah.
So we got to change that a little bit. So we're going to do like 0, and we'll do like 0.25, 0.5, 0.75, and then 1. All right. And so what we need to do before we could graph this is I need to plug in x equals sine of 2 pi times 0. All right. So somebody, what's that? Well, 0 times 0 is, or 0 times 2 pi is 0. So what's sine of 0? 0. So this the x value is going to be 0. Now, if I want to do the y value, I'm going to say sine of, or not sine of, cosine of 2 pi times 0. So what's cosine of 0? 1. So now I'm going to graph this. Now, if it's a circle, I really don't need to go any further. If it's a circle and it has the point 0, 1, what's the radius? 1. Okay. So now on your calculator, real quick, you guys do me a favor. Plug these in to your calculators as the parametric curves, and then set t equal to 1. And so maybe I can help you guys out with that. Let me pull up my calculator. So if I come in here and I plug it on my calculator, I want to go to second mode. I'm going to come down here to parametric. Then I'm going to hit graph, and I'm going to put in sine of 2 pi times t. Then for y, I'm going to plug in cosine of 2 pi times t. Then I'm going to go to window, and we're going to go from 0 to 1, right? And I'm going to make the step like 0.1. I'll make it small. Or no, let's do 0.25. Because that's what I have in my table of values. So now if I hit second table, I'll get the answers that I'm looking for. So, oh, but it didn't do the step the way I wanted. So now I got to come back and do down here where I do the delta table. I need to do 0.25. And so now when I do that, now I'll get. So when my answer is when t is 0.25, I've got 1 comma 0. When t is 75, I've got negative 1 comma 0. No wait, 0 comma negative 1, and then 0.75 is negative 1 comma 0. And then 0 comma 1. And so if we come back to this, what I have here is I basically have the unit circle, right? So as I come around, I'm just going to have all these points. And so I have a circle here. Make the dots bigger. With a radius of 1. So the equation of a circle with a radius of 1, if I write this out, my equation should be x squared plus y squared equals r squared, right? But we think that r, the radius, is equal to 1, so I should have x squared plus y squared equals 1, right?
Yes.
So what I need to do now is, what does x equal? Well, x equals sine of 2 pi t, all that squared, plus cosine of 2 pi t, all of that squared, should equal 1. And it does. That's the Pythagorean identity. Because if I let theta equal 2 pi t, then sine of theta squared plus cosine of theta squared does equal 1. And that's true.
Hey, Mr. Adams,
Yeah.
on my graph, my circle doesn't complete.
Oh, does it go all the way around?
No, mine doesn't.
It should. It's probably,
Wait, is yours?
give me your calculator. You probably have to, is your t set all the way to 1?
Yes.
Okay, so here's a question I'm glad she asked. Oh, it's the steps. So you guys look at this. I want to show you this. This is a good one. We ran into this the other day. So it should be a perfect circle, but as you can see, her circle's a little choppy. All right? Now what this has to do with is it has to do with the increments. Okay? So if we go in here, the increment is at 0.13. We need to make it like 0.1. That would be good. You could even go a little smaller. You could go like 0.01. Oops, not point. You can go 0.01. Now what that does is it's going to plug in smaller increments of t, which will give you a smoother curve. So now if I graph it, it's a perfect circle.
Yes.
Well, it's a little skewed. If I go into Zoom Fit. Now, you know what though? These calculators, they're a little skewed a little bit, so. But if I do Zoom Fit, Yeah, it still ends up looking like an ellipse, but the radius is 1, right? Because this tick mark is a 1, this tick mark is a 1, and so that's a circle. Okay? Any questions? Okay, cool.